Hi, in this video I'm going to be talking about problem 6.37, which was number 13 on the chapter 6b homework. So the problem asks, at what distance from the center of the Earth is the center of the Earth-Moon system? And suppose that the mass of the moon is 7.35 times 10 to the 22 kilograms. Okay, so center of mass, we know, is the weighted average, the literally weighted average, of the positions of all the objects in the system. Okay, so the position of the center of mass is going to be M1 position 1 plus M2 position 2 divided by the sum of the two masses. Okay, that seems fine. And they've given us the mass of the moon, so we've got one of them. I actually got several messages from people saying, I don't know how to proceed from this because it seems like they haven't given us enough information. And you are correct. They have not given you enough information. And that is okay. Sometimes you don't have all the information. So let's put in what we have. We have 7.35 times 10 to the 22 times the position of the moon. Okay, and then we need the mass of the Earth times the position of the Earth divided by the mass of the moon. We've got that one, 7.35 times 10 to the 22 plus the mass of the Earth. Okay, so how do you figure those things out if they haven't given them to you? You actually get to do Google research in this case. So I'm going to bring in another browser right here, which also has my calculator in it. And we're going to look it up. We're going to find out what is so we need the mass of the moon, the mass of the Earth, and the position of the Earth. So mass of the Earth. Look it up. And we get 5.97 times 10 to the 24 kilograms. Okay, so mass of the Earth, 5.97 times 10 to the 24 kilograms. I often round that up to 6. And then this one is going to become 5.97 times 10 to the 24 times the position of the Earth. Okay, so now we need the position of the moon and the position of the Earth. Okay, now position is always relative to some coordinate system. So position of the moon relative to what? Position of the Earth relative to what? Okay, well, the problem statement says relative to the center of the Earth. At what distance from the center of the Earth is the center of mass of the Earth-Moon system? Okay, so basically that means we're taking the position of the Earth as the 0 point, and then whatever the distance out to the moon is, put the moon way out here, center of the moon. So what's the position of the Earth in this coordinate system? The position of the Earth is 0. Xe equals 0 because it's on the origin of this coordinate system. So this xe becomes 0. All right, and then the position of the moon is whatever that distance is from the center of the Earth to the center of the moon. Okay, so we need to now look up what is the distance between the Earth and the moon. Distance from the Earth to the moon. And yeah, I probably want that in kilometers. Oh, it gave it to us in miles. 238,000 miles. Okay. So let's figure that out. So position of the moon is 238,900 miles. This is another thing you can look up if you don't happen to know it. 1.609 kilometers in 1 mile. So times 1.609 km divided by 1 mile. So the position is 238,900 times 1.609. We have 384,390. So we'll round that up. 384,000 kilometers. And so to put that into base SI units, that would be 384. It would be 3.84 times 10 to the 5th kilometers, but I actually want it to be in meters, so it's 10 to the 8th meters. Okay, so that 3.84 times 10 to the 8th goes in right there. 3.84 times 10 to the 8th. Okay, so it's just a little bit ugly to put all this together, and we have to make sure that we get the precision of it right. So the top of the fraction is 7.35 times 10 to the 22 times 3.84 times 10 to the 10th. So that's the weighted position of the moon relative to the Earth. And then that whole thing gets divided by the sum of those two masses. So 7.35 times 10 to the 22 plus 5.97 times 10 to the 24. And what do we get? We get 1, 2, 3, 4, 5, 6, 7, 8. 4.67 times 10 to the 8th meters. That doesn't sound right. Okay, I don't know quite exactly where I left off, so this cut is probably going to look kind of funny in the video. But I've been spending the last couple of minutes trying to track down what's going on because this number doesn't sound right. I wrote down 4.67 times 10 to the 8th meters, and that's larger than the distance from the Earth to the Moon. It really doesn't make sense for the location of the center of mass to be over here if the system is those two things. The center of mass ought to be in between them, and it ought to be, much closer to the position of the Earth. Okay, so what did I do wrong here? So first thing I should do is work backwards from the most recent thing I did to see if there's any issues with it, and then I can work all the way back to the top where I can figure out, oh, maybe I had some fundamentally wrong misconceptions. Okay, so 7.35 times 10 to the 22 is the mass of the moon. That was given to us in the problem. 5.97 times 10 to the 24 is the mass of the Earth. I looked that up. Okay, that's fine. And then the top, I should have a 0 here because the Earth is on the center of, is on the origin of the coordinate system. And this one should be 7.35 times 10 to the 22 times 3.84 times 10 to the 8th meters. And that's where the issue is. I wrote a 10 right there. I'm not quite sure why I did that. So that exponent should be an 8. Boom. That's better. That moves that decimal place over a couple. 4.67 times 10 to the 6th meters is the location of the center of mass. Let's think about that. If this is 3.84 times 10 to the 8th, which is 38 million meters. This should be, actually no, 380 million meters. Then the 4.67 times 10 to the 6th, that's 4 million. So it's 380 million the whole way. This is 4 million meters. This is much closer to where the Earth is, or to where the center of the Earth is. And we could figure out exactly where that is relative to the surface of the Earth. So 4.67 times 10 to the 6 meters is 4 million meters, which is 4,000 kilometers. That's less than the radius of the Earth. The radius of the Earth is 6,400 kilometers. The center of mass is somewhere in there, relatively close to the surface, but it's not beyond the surface. The fact that the center of mass of the Earth-Moon system is in the Earth is related to the fact that there are tides. You can think about that. So anyway, 4.67 times 10 to the 6th. Let me put that in. Oh, I show you the solution view where I track down my mistake. but 4.67 times 10 to the 6th meters is my solution. And there we go.